Hello, everyone. So today we're going to be covering lesson 716. Before we get into that, though, I just want to review the two special right triangles, the 30, 60, 90, and the 45, 45, 90. Now, if these were drawn in the unit circle, that would mean that the hypotenuse on each of these would be the radius. Well, in the unit circle, we know that the radius is 1. Okay, so I'm going to go ahead and give 1 to each hypotenuse. Now let's look at this 30, 60, 90. So in the 30, 60, 90, the hypotenuse is the 2x side. The shorter leg is the x side. So if I wanted to figure out the shorter leg, I would have to take the hypotenuse and divide it by 2. So the shorter leg is 1/2. Okay? Now, if I want to figure out the longer leg, I know it's going to be the x square root 3 side. So that means 1/2 times the square root of 3. So that would be square root of 3 over 2. That's 1/2 times the square root of 3. Okay, so kind of commit that to memory. We're going to be coming back to that or revisiting that later on in this lesson. As far as a 45, 45, 90 goes, well, the hypotenuse is the x square root 2 side. The two legs are the x sides. Okay, so let's do what we did before. So this is saying that x square root 2 is 1. Okay, we want to figure out the x side. So if we divide by square root 2, that's all fine and dandy, but we need to rationalize our denominator because we can never have a radical in the denominator. So when we do that, we get that x is the square root of 2 over 2. So that would be both of these legs on the 45, 45, 90. Okay, so for now, just commit that to memory. We will be revisiting that in just a bit. Okay, all right, so let's get into 716. So today we're going to be really focusing on this unit circle. We're going to be building a unit circle using radians. So it says, in this lesson, you will further develop your understanding of the unit circle and how useful it can be. By the end of this lesson, you should be able to answer the questions below. What can the unit circle help me understand about an angle? And what does my information about angles in the first quadrant tell me about angles in other quadrants? We kind of talked about this already as far as reference angles, so that's going to come back today as well. Okay, so let's go ahead and look at 86. It says there are some angles for which you know the exact values of sine and cosine. In other words, you can find the exact sine and cosine without using a calculator. Work with your team to find as many such angles expressed in radians as you can. Okay, so this is the first place that our special right triangles are going to come into play. All right, now remember when it says exact values, that means no decimals. That means in radians, that means in terms of pi. When you're actually figuring out the values, that means radicals. So that's why when we just did our special right triangles on that first slide, we left them in radical form. So some of these angles that we know already, well, think of your 45, 45, 90s, or in your 30, 60, 90s. So we know the 45, we know the 30, we know the 60, we know 90. We can also figure out 180, 270, and, move this out of the way, eventually 360. Okay, but it does say in radians. Okay, so in radians, the 45 is pi over 4. The 30 is pi over 6. The 60 is pi over 3. The 90 is pi over 2. The 180 is pi. 270 3 pi over 2, and 360 is 2 pi. We've discovered these already, so this is not new information, but these are just kind of these like kind of the main angles that we've been dealing with. Now we can also, these are all like, well, up till 90, these are all first quadrant, right? Well, we know because we can use these as reference angles. So because that unit circle is going to keep going around, yes, we have pi over 4, but we also can have 3 pi over 4, right? That's the one that occurs in the second quadrant. There is also 5 pi over 4. That's the one that occurs in the third quadrant. And then finally, there's 7 pi over 4. That's the one that occurs in the fourth quadrant. And I'm going to give you a visual of this in just a minute here. Okay, so just hang on. As far as the 30, think reference angles. So visualize what we looked at with reference angles. So in the first quadrant, it's pi over 6. Okay. In the second quadrant, it would be 5 pi over 6. Okay. In the third quadrant, it would be 7 pi over 6. And in the fourth quadrant, it would be 11 pi over 6. Okay, and again, I'm going to give you a visual of all of these in just a minute here. All right, so if you're like, where is she getting these from? Just hang on. I will show you the visual. You'll be able to see. Okay, how about pi over 3? Well, that's the first quadrant, right? So in the second quadrant, it's going to be 2 pi over 3. Okay, in the third quadrant, it's going to be 4 pi over 3. And in the fourth quadrant, it is going to be 5 pi over 3. Okay. Now pi over 2, that's where 90 is, so that's where the quadrants kind of split off, or like quadrant themselves out. So the 90, the 180, the 270, the 360, those lie on our axes. All right, so those are kind of given already. All right. Now, in number 87, this is where you need your resource page, okay? It says, now you will build a unit circle, obtain the 716 resource page, so you should have that. It looks like this, a unit circle, a blank unit circle. It says that there are points shown at pi over 12, pi over 6, pi over 4, pi over 3, etc. units along the circle, starting with from the positive x-axis. So for part A, it says find and label the exact coordinates, meaning the x, y, for 3 of the points shown in the first quadrant. I made this a little bit smaller just so it would fit on the screen a little bit better. So hopefully all of this works out okay. So on this unit circle, you can see that there are dots for, like, starting with pi over 12. So they're in those increments. So that represents 15 degrees. We'll come back to that in a minute. We're going to start with kind of our main angles here. So this is where pi over 6 would show up. This would be pi over 4. And this would be pi over 3. Now, as far as our other kind of main angles, okay, so we start at 0 here. This one right here would be pi over 2. This is pi, and down here is 3 pi over 2. Okay, so those are kind of our main angles, and as when we think reference angles, these are the ones that come to mind. So let me start out with the ones that are right on the quadrants. So if I start at 0 or 2 pi, because that's our starting and our ending, well, the unit circle has a radius of 1. Right? So that means that from here all the way out to this this point here, that is 1 unit. So the coordinates here are 1, 0. Okay? We can use that same idea for pi over 2. Okay? Only here we didn't go anywhere on the x, we went over 1 on the y. For pi, it would be -1, 0. And for 3 pi over 2, that one would be 0, -1. Okay, and again, that's just because the radius, it's directly on an axis, so that's why those are the exact coordinates of those kind of like main points. Okay, now how about the rest of these? Well, pi over 6 corresponds with 30 degrees, right? So if I draw in, and I won't do this for everyone, I'll just do it for this first one. This one is 30. Okay, so if you think back to what we did with special right triangles in the beginning, we said that this was 1. We said that this was square root 3 over 2, and we said that this was 1/2. Okay, so for 30 degrees, that would mean that the coordinates, the x coordinate, square root 3 over 2, the y coordinate, 1/2. Okay, we can do the same thing for pi over 4. That represents that 45, 45, 90. Okay, again, I'm not going to draw it all in here to make it, actually I can use a different color. So if I go here, For 45, again, this is 1. This is square root 2 over 2, and this one right here is square root 2 over 2. So the x, square root 2 over 2, the y, square root 2 over 2. Okay, now for the pi over 3, that is a 60-degree angle. Okay, so 60, I know this is all overlapping. Again, this is 1. This is where the square root 3 over 2 would be. And this is where the 1/2 would be. So the x coordinate is 1/2. The y coordinate is square root 3 over 2. Okay, now we talked about reference angles earlier. We're going to use that idea of reference angles to fill in the rest of this unit circle, okay? And they're all going to have to do with the 30, the 45, and the 60. Okay, so as I'm moving along my circle, if this is pi over 3, this one right here is 2 pi over 3. If this one right here is pi over 4, this one right here is 3 pi over 4. And if this one is pi over 6, then this one right here is 5 pi over 6. Now I should be able to use the same coordinates, only I may have to change like positive, negative, depending on the quadrant, okay? So the coordinates for 2 pi over 3, well, the x is going to be negative. So that's going to be negative 1/2 then square root 3 over 2. So again, I'm looking just at these coordinates right here. I'm just changing the positive negative. Okay, for my 3 pi over 4, again, the x coordinate is going to be negative. So negative square root 2 over 2, and then square root 2 over 2. For 5 pi over 6, that corresponds with that pi over 6. Again, the x coordinate is going to be negative. So square root 3 over 2, positive y 1/2. Okay, so that's quadrant 2. In quadrant 3, if we continue on, I know there aren't dots here, so I'm going to do my best to kind of estimate. Let's see, it might be something like this. Okay, so this one, 7 pi over 6. This one, 5 pi over 4. And this one is 4 pi over 3. Again, we're going to use the 30, the 45, and the 60 with those same coordinates, only adjusting for the positive and negative within the quadrant. So both x and y are negative in this quadrant. So 7 pi over 6, that corresponds with that pi over 6 coordinates. So square root 3 over 2 negative, and negative 1/2 would go there. For 5 pi over 4, that would correspond with that pi over 4. So negative square root 2 over 2, negative square root 2 over 2. For 4 pi over 3, that corresponds to that pi over 3, only again, they'd both be negative. So negative 1/2, negative square root 3 over 2. Okay, now our final quadrant. This is quadrant 4. Again, I'm going to try my best to estimate the positions of these points, maybe like that. So this one here is 5 pi over 3. This one here is 7 pi over 4. And this one here is 11 pi over 6. And again, you just kind of match up with their reference angles. So we have 11 pi over 6. The x is positive, the y is negative in this quadrant. So square root 3 over 2, negative 1/2. For the 7 pi over 4, square root 2 over 2, negative square root 2 over 2. Sorry for the messiness there. And then finally, for 5 pi over 3, I'll write it on the inside here. It's going to be 1/2 and negative square root 3 over 2. There we go. So we just built our unit circle with our main angles. So we have the ones right at the quadrants that represent the differences of 90 degrees all the way around. And then we have the 30s, the 45s, and the 60s for reference angles. Okay, so now moving on to number 88. So 88 says draw a new unit circle, or you can use the same one. I just chose to just do another resource page here. It says draw a new unit circle, label a point that corresponds to a rotation of pi over 12, and put your calculator in radian mode. Okay, so grab my calculator. So let's take a look at these pi over 12 increments. These are like the 15-degree ones, right? Okay, so pi over 12 is here. That corresponds with that 15-degree angle. All right, so that's not one of our special right triangle angles, right? So we're going to have to use our calculator to figure this out. So make sure your calculator's in radian mode. Remember that the cosine corresponds with the x-coordinate. The sine corresponds with the y-coordinate, okay? So if I go cosine of pi over 12, I get 0.97 for the x-coordinate. If I go sine of pi over 12, I get 0.26 for my y-coordinate. Okay, we probably wouldn't have been able to figure those out other ways, all right? So now, if I look at part B, it says use the information you found in part A to determine each of the following values. Okay, so the next one there is negative, or the sign, excuse me, of negative pi over 12. Well, negative is moving in this direction, right? So negative pi over 12 is here. It's also 23 pi over 12 if you're going the other way. Okay, so again, there's that 15. We want to figure out the sign of that. Okay, well, in this quadrant, that y coordinate is negative. So the sign would be negative, here, I'll write on the inside, negative 0.26 is the sign because that's the y coordinate. The next one, the cosine of 13 pi over 12. Okay, well, pi over, or 12 pi over 12 is here, so 13 pi over 12 would be here-ish. Okay, so this is 13 pi over 12. Okay, so if I want the cosine, I want the x-coordinate. In that quadrant, the x's are negative. So that means that the x-coordinate, or the cosine, is that. All right. And then number 3, it says the challenge, 7 pi over 12. Well, 12 pi over 12 is here at pi, right? 6 pi over 12, that's halfway, that's here. So 7 pi over 12 must be this guy. Okay, so 7 pi over 12. 12, I keep printing the 1. Okay, so if I say, well, the cosine of 7 pi over 12, that is going to be negative 0.26. If I want the sine of 7 pi over 12, that's going to be 0.97. Look what happened to those coordinates. They just kind of flip-flopped there, right? And you can look back at your unit circle and you can see some of those same patterns as you move from quadrant to quadrant. Okay, so number 89, we're not going to cover that in this video. If you'd like to kind of go beyond or challenge yourself, feel free to go work through that. The last thing I want to do is just revisit those questions from the very beginning. Okay, what can the unit circle help me understand about an angle? And then what does my information about angles in the first quadrant tell me about angles in other quadrants? Well, hopefully we answered those questions as we went through this. So the unit circle can help you understand that all of these angles are cyclic, meaning they keep repeating, right? Especially with those reference angles. And then what does the information about angles in the first quadrant tell me about angles in other quadrants? Well, again, with those reference angles, the coordinates are going to be very similar. It's just a matter of a positive or a negative. Okay, so hopefully we answered those questions for you. Thank you for sticking with me to the end of the video. I will see you tomorrow. I'm going to be gone next Monday, so I had to record my lesson.